My name's Nick Holthouse. I'm the CEO of Meteoric Resources, and I'd like to take you through a presentation for the Caldera project. The Caldera project is located adjacent to the city of Poços de Caldas in the state of Minas Gerais in Brazil. Just a quick look at the disclaimer. If anyone has any questions on the disclaimer, please feel free to contact me at Meteoric Resources. Just a brief company overview. Meteoric Resources has been around for the last 20 years or so in various capacities. It's a resource company listed on the ASX in Australia. It's had forays into uranium, gold, iron ore, and other commodities within this space. But more recently and more exciting to us is the recent acquisition of the Caldera project in Brazil, and the tack that we are now taking to exploit that project and take that project forward. Dr. Andrew Tunks is the chairman of the board. He's an industry warrior in Australia. He's been around for a long time, a PhD geologist. Our executive director is Dr. Marcelo de Calvo. He's also a PhD geologist, a Brazilian national, who is now working in our government relations space as well in Brazil and doing a fantastic job. And we have Dr. Paul Kiddo, a third PhD geologist, who's been around for a long time, also based in Australia as well, and myself as Chief Executive Officer. Just be aware that I'm not actually on the board of directors. I am the Chief Executive Officer. So, rare earth elements. I'm sure most of you will be aware of the story behind rare earth elements and especially their significance in the last few years. There are four rare earth elements that are really drive the story, I guess, and they are neodymium, praseodymium in the light rare earth space, and terbium and dysprosium in the heavy rare earth space. And they really are focused on the magnet story. And the magnet story is really what is driving the rare earth story at the moment. It's the powerhouse behind the demand for the rare earth elements. It's certainly in the EV space and to a lesser extent wind generation, although very close as well. And for us, it's really we're really focusing on trying to get those four elements into the market. A little bit of an overview. Predominantly, China's been very dominant in this space for a long time. They mine around 60% of the world's rare earth elements, with the USA and Australia very close behind that. Myanmar is an interesting case. It's a little bit opaque. It's predominantly used by China as a buffer to regulate the market in their space. So 60% coming from China, but if you look across to the right, you'll see that China certainly have a stranglehold in the magnet supply place, and this has been very well documented in the media over the past few years, with some of the supply chain issues that we're facing in that space. And they manage that through imports from the USA, imports from Australia, and certainly imports from Myanmar fill that gap, bring China's dominance up from 60% in the mining space up to 91% in the magnet supply space. And they're very keen to keep control of that, which leads on to some of the issues that we'll talk about a little bit further on in the presentation with regards to pricing and other things. As I mentioned before, predominantly rare earth elements are used. For us, it's really a magnet story. We are looking to supply into the EV and wind turbine power generation space, but they have a multitude of other applications. There are 15 rare earth elements in total. As I mentioned before, it's the four elements: neodymium, praseodymium, terbium, dysprosium, which really are a focus for us, and really drive the bulk value in our basket, and with the other elements that come along to a lesser extent in other industries. Some of the differences that you see between an ionic clay deposit and a hard rock deposit. I have just come from the hard rock space. I've spent 5 years developing a project in Australia, and just a monazite, hosted in an ironstone, hosted inside a granite, so very difficult operating conditions. But predominantly the ionic adsorption clay story was welded to China. And it's something that they've been able to exploit quite successfully in the past because, and very low grade deposits too. We're talking deposits down to 500 ppm up to around 1200 ppm, so not particularly high. But they've made these deposits work through artisanal mining, essentially. Lots of backyard operators with fairly low ESG standards has allowed them to ensure that they have a regular supply of carbonate coming across the border from Myanmar and within China itself to supplement their own industry. So it's for them, it's a very low cost option and not something that we've typically seen in the West. More recently, though, ion adsorption clay deposits have become more popular in the West, and we are certainly seeing some movement in that space. Brazil is certainly becoming a hub in the ion adsorption clay area. There's 4 or 5 operations now, projects which are looking to go forward in that space, as well as Australia and other places. The scale of these things, the capital intensity, the flow sheets in an ion absorption clay are very simple and very, very different to what you see in the hard rock space. It's a very simple process to dislodge the rare earth elements from the clay particles. They adhere to the outside electrostatically, and to remove those rare earth elements, it's the simple introduction of a reagent which has a similar or stronger positive charge to dislodge those elements. That it's as simple as that. So it's a very simple process. In the hard rock space, you are dealing with the original parent minerals, the very robust minerals, and quite a bit of work is involved in breaking those minerals down. Essentially, you need to produce a concentrate first. And these elements are hosted in hard rock, so you need to drill and blast. You need to crush and grind. You need to produce a floated concentrate of some sort with bespoke reagents. You then need to take that concentrate and break down those robust minerals inside that concentrate with the application of a significant amount of acid and heat, typically in a kiln. That generates lots of bespoke off gases which need to be managed, and also these deposits are typically higher in tenor of uranium and thorium, so there's the uranium thorium issue to manage the back end as well. All that equals an expensive flow sheet, complicated flow sheet, and an expensive capital cost to build that flow sheet. The ion absorption clay is much simpler, so we have a lower operating cost, lower capital cost, and that's really the advantage for this deposit. Exploration, because it's a clay, the exploration, and they're fairly typically from surface, the drilling is cheap and relatively inexpensive compared to hard rock drilling. That's probably well understood. Mining, as I mentioned before, in the clay space, there's no drill and blast. We simply peel back the topsoil. The rare earth elements are available at surface essentially, and we can free dig those clays and get them into the process. Whereas in a hard rock area or hard rock situation, you are looking at more expensive drilling, mining costs around drill and blast, and then crushing and grinding to liberate those minerals. And as I mentioned before, in the processing side of things, the fact that we have a very simple flow sheet, ammonium sulfate, which is essentially a liquid fertilizer, is the main reagent that we use. We don't use pressure. We don't have to use temperature. We don't need a low pH environment to liberate these minerals. They dislodge themselves very easily with a very simple ammonium sulfate wash. A little bit on the pricing. The graph on the left really tells a very strong story. Last year, we were experiencing a surge in the demand for EVs and wind turbine generation. That was leading to improved prices around the NdPr space. NdPr in the basket, or neodymium praseodymium, really is the key indicator when you look at the metrics in any sort of rare earth operation. And at those prices, certainly an attractive proposition for all projects to get off the ground and get started. But there has been some market manipulation, as you can see in the sawtooth graph on the left, and the price has been dropped. And that has been dropped by quotas being increased in China. They've opened the the borders with Myanmar and allowed quite a bit of carbonate to come back across that border from illegal operations or artisanal operations to add to the Chinese inventory, which has created an oversupply for the lights, and that's why you've seen the price drop. Now, that is the current price where it is, down around $60 per kilo of NdPr, is certainly an issue in the hard rock space. A lot of the newer projects certainly will not be getting funded at those sorts of prices that we're seeing at the moment, and their operating costs are certainly above $50 or $60 a kilo of NdPr. However, in the ionic clay space, with our grades and recoveries, we are operating, we will be looking to operate well below that $50 to $60 mark, something closer to $30 per kilo. So even under those challenging conditions, projects like the Caldera project are certainly able to go forward and keep operating. It makes the Caldera project, the operating metrics, very robust, and allows that project to endure those sorts of price manipulation scenarios. A little bit about the exploration. The tenements that you can see with the red dots are actually drill hole collars that were drilled out between 2016 and 2019 by JOGMEC. JOGMEC is a Japanese government institution that roams the world looking for resource opportunities to feed back into Japanese OEMs. So they spent 3 years drilling the Caldera project up until the advent of COVID. That and some untenable royalty conditions that were imposed in the contract forced the Japanese to essentially walk away from the project. They gave the data set back to the tenement owners, and that project essentially lay fallow until Meteoric was able to engage with the vendors and secure that asset. So the drilling was undertaken over 6 mining licenses. These are granted mining licenses, and that's quite a process in Brazil to get mining licenses granted. However, these are clean and clear and ready to go. The drilling was done by hand auger and very shallow, so anywhere between 6 to 8 meters in depth. The interesting thing is that over 85 to 90% of the holes ended in grades above 1,000 ppm. Now, this is significant. What it's telling you is that the resource in all those 6 deposits is open vertically. It's open at depth, and that was certainly a question that was hanging over us at the time when we went through the process of delivering the maiden resource. What other opportunities are below that? So, of course, with a strong focus on geology with our board especially, getting drills to work was certainly a first priority. The slide on the left is interesting. It really, I guess, it demonstrates what I was just talking about with regards to shallow drilling during the JOGMEC program. You know, we really needed to understand what was at depth and what opportunities there were to grow that resource beyond that. So we got a diamond drill to work. It was a 2-pronged approach. We really wanted to understand what opportunities there were, where the basement lay, and so what opportunity to grow that resource in a vertical sense on those 6 tenements. And secondly, it was really to gather additional metallurgical test work samples so that we could advance our test work program with ANSTO. ANSTO is a research facility based in Sydney in Australia. They are very well versed in metallurgical test work, particularly in the rare earth space, and we've engaged those guys to go forward. So a drilling program was undertaken. There was 41 holes planned over all the 6 licenses. At the current time, we have results back for 27 of those holes, and there was a release that went out to the market not so long ago, which really gives some detail around that, around what we were seeing with regards to additional depths, additional grades, and the met test work is something that work package is about to start very shortly. In the map on the right, you can also see those areas in green and grey. They are additional land acquisitions that Meteoric has undertaken in 2 separate tranches since the original acquisition of the 6 mining tenements. So what we've really done is we've tried to consolidate our position within the caldera. You can see the caldera there in the light green, a ringed area. It truly is a caldera. It looks like a meteorite impact crater when you stand on top of the mountain range that rings the caldera. It's a closed environment with regard to water. Any rainfall that falls within the caldera itself cannot escape. And this is probably one of the reasons why we're seeing that those very high grades in these clays over time, as they've weathered down on the primary source, the primary granites below the clays in the caldera. They've had the molecules, the rare earth elements, have had no opportunity to escape that area. So they've been basically become enriched over time in that closed environment as they've weathered down. So as you can see, we've got quite a foot on the current tenement package within the caldera. There's certainly a lot of interest. The areas in the grey and the green are not mining licenses. Some are exploration licenses and some are applications. So they are in varying states of good stead with regards to mining, but we will certainly be working on those over the coming years to bring them forward and assess the opportunities that lie within them with an exploration program. But at the moment, within those red areas, or the areas with the red dots, the 6 granted mining leases, that is where our current resource at 409 million tonnes at 2,600 ppm lies, with great opportunity to grow vertically as we continue to drill. Just a little bit more information on the recent drilling program that we've had. We have seen significant increases in the depth with the limited amount of holes that we've put in so far with the diamond drill rig. So we're seeing anywhere between 16 to close to 60 metres in depth below what we currently have in the resource estimate. So it's going to be interesting to see what those numbers come in, but it's probably safe to say that we're looking at a resource now in excess of 1 billion tonnes. So a significant number at a significant grade. The grades seem to continue at depth as well. We're seeing more of the same, essentially, with some very discrete high-grade zones amongst that as well. Additional drilling for those areas to infill over time. The focus for us at the moment is the 2 tenements that you can see in the south, the Capo de Mel tenement and the Suburbo tenement. We are seeing very high grades there. It is also what we consider to be a good place to start with our main processing plant facility. So the MET test work that we're going forward with and the infill drilling program, which I'll talk a little bit more about later, are really focused on those 2 southern tenements. The other 4 tenements to the north, we will be focusing on after we get Suburbo and Capo de Mel away with our engineering studies going forward. This really just highlights the resource that came out. So we've mentioned these numbers before. The bottom line is with 409 million tonnes at 2,600 ppm. As I said before, it's a world-class asset. There's no other clay deposit, iron adsorption clay, not primary mineralisation in clay, which you see a lot of out there, but this is a true iron absorption clay at those grades. We certainly haven't seen anything that's better than this resource at the moment. And as I mentioned before, the ability to grow this resource over time, over the next 12 months and going forward from there is immense. This is an interesting graph. The grade tonnage curve. There's a couple of key takeaways from this. One is that you'll notice at the 2 cutoffs of 0 and 500 ppm, the 2 very left-hand columns, you really see no change with those. As those cutoffs are applied statistically to the data set, you see no real change. In fact, right up to 1,000 ppm, you see a very slight change. What that's telling you is that there are no samples within our data set which sit below 1,000 ppm. This is a very high-grade deposit. There is nothing below that 1,000 ppm data set that sits within there, which is why you're seeing no change to the tonnages with those cutoffs applied. This is truly exciting. For us, and for me as a mining engineer, and taking the project forward, the area that I'm really focused on is at the 3,000 ppm cutoff. We have over 100 million tonnes at over 4,000 ppm TREO, and the majority of this material lies in the Capo de Mel Suburbo tenements, which I was talking about in the previous slide. That is really where our studies are focused on in the short term. We want to grow the resource in that area, want to grow that 115 million tonnes at plus 4,000 ppm significantly with a drilling program, which is about to start soon, an infill drilling program. And our MET test work is really looking at optimising what we're seeing in those two southern tenements with that data set. And it's certainly the focus for our first plant to be in that area. A little bit about the basket. As I mentioned before, there's four main elements: terbium, dysprosium, neodymium, and praseodymium. Terbium, dysprosium being the heavies, and neodymium and praseodymium being the light elements. These four elements make up about, in our carbonate, our precipitated carbonate, praseodymium, neodymium make up about 30% of the basket, or 30% of the total proportion of rare earth elements that we see. And terbium and dysprosium make up about 1%. That 30% of neodymium and praseodymium equates to about 80% of the value of the basket. And when terbium, dysprosium, they do an awful lot of heavy lifting. At 1% of the volume of the basket, they contribute to about 14% of the value of the basket. So clearly, for us, in our mining schedules going forward, we really are going to be looking at opportunities to increase not only our mining schedules, but also in our MET test work. We really want to look at opportunities to try and increase our mining grades around terbium, dysprosium, bring them up to 1%, even bring them up to 2%, making an enormous difference to the value of our basket. And making sure that we schedule those, and we also maximise the recoveries in that space as well. Again, the recoveries that we see at that ammonium sulfate leach, around 70% for all those elements, indicate that this truly is an ion absorption play, and that has, as I said, it's one of the great hallmarks of this project. It reinforces the fact that we have a very simple flow sheet. We're going to have a very low capex, very low operating cost. Really important things. This is a slide showing, I guess, the 6 steps for us to get to a magnet. We do the first 2 steps on site. We do the mining and we do the beneficiation. So at the end of step 2, we have a carbonate. Now the carbonate, I guess, is a middle stage concentrate. It's a mixed bag. It has all the 15 elements inside it. The next step is the oxide separation. That is not something that we're planning on doing on site immediately. It may be an opportunity that we look at further down the track after we get steps 1 and 2 bedded in and get the project up and running. But at this stage, oxide separation, metallisation, alloying, and magnet creation are going to be done elsewhere, and we are looking north for those last remaining 4 steps. We are looking into North America, and we're looking across to Europe with partnerships. Possible partnerships, possible JVs, possible mergers going into that space to deliver magnets to the North American, European market, downstream OEMs. This is one of the 2 tenements that I was talking about a little earlier, Capo de Mel. As I said before, this is an area that we'd like to get started on. Anything with the yellow, red, and pink is extremely high grade. I guess it really demonstrates the scale of what we're seeing with regards to high grade material in those southern tenements, and why we'd like to start the operations in that area. The green arrows below, they lead into a secondary acquisition, tenement acquisition that we've had. It's not a granted mining lease, it's an exploration license. But clearly, an exploration focus for us going forward is to chase that trend, that the pink and red trend that you can see there, south into those tenements and seeing what opportunities lie there. I really believe that we're going to have a multi-generational plus 4,000 ppm operation sitting in that southern area for quite some time, for many decades. This is a simplified slide showing what the process looks like. As I mentioned before, the mining is quite simple. We simply push off the topsoil, mine the clays. The clays are washed and screened with water, turned into a slurry. They go into a tank, maybe 1 or 2 tanks. At that point, the ammonium sulfate is added. And again, this is a liquid fertilizer. We'll be buying this by the bulk tanker from fertilizer producers. There are many fertilizer producers around the Poços de Caldas area. It's a large agricultural area outside the caldera. The caldera itself is with the alkaline soils is quite poor, but outside the caldera, very high value farming areas. So lots of agricultural pursuits going on, lots of fertilizer available. The ion exchange process, as I mentioned before, happens very quickly. The clays go into solution, the ammonium sulfate is added, and you get to 70% recovery somewhere between 5 to 10 minutes. So very, very quick. What that means, the faster it happens, the smaller the vessels that you need, the smaller the plant. So all these are things, all the recoveries, the flow sheet, they're all hallmarks that lead to a low capex, low opex operation. Very simple technology. There's an impurity removal stage. So this is getting rid of elements such as iron and aluminium. We really don't have much in the way of uranium and thorium. In fact, there's no, at this stage, from the maiden carbonate that was precipitated through the Japanese test work, the tenors of uranium and thorium that are in that carbonate can go straight to the processors. There's no penalties at this stage, but we were certainly looking to reduce those where we can too and attract a premium for our carbonate product. The impregnated ammonium sulfate, which has now dislodged the rare earth elements, goes into a second set of tanks. There's a carbonate that is added. There are lots of different carbonates that you can use in this process. So the test work that we're undertaking at the moment is looking at all those opportunities. The sludge that drops out during that precipitation phase is pulled away, is dried, and that is the final product. It's as simple as that. It really is a very, very simple process. It happens very quickly, happens very cheaply. The clays, the remaining clays or the spent ore is then washed, rinsed with water. The ammonium sulfate is recovered. We're looking to get something like a 95% recovery for our ammonium sulfate in that process, so we can reuse that ammonium sulfate again and again, essentially. The clays are washed, they are filtered, they are returned to a consistency that can go back into a truck, and then they go back to the mined out areas and are sequentially backfilled. Topsoil is placed over the top and rehabilitation takes place. So no tailings dams, no waste dumps. This is a bit of a timetable for our work front going forward. We're getting very busy on the ground. We're starting to build up the team in Brazil and in Perth as well at our head office here. We talked about the phase 1 diamond drilling before with those 41 holes. That is now complete. Phase 2 diamond drilling is underway, and that is really looking at the greater exploration areas, the tenements that we're seeing outside those 6 mining licenses. We're starting to do the work that is required to bring those tenements into good stead and take them forward in the application process, so we can begin converting them from either applications or exploration licenses into mining licenses. Metallurgical test work, really important stuff. This was started 2 weeks ago now at the ANSTO facility in New South Wales in Sydney. That is about a 12-month program. So step 1 for us is really to look at the carbonate. We're looking to see what improvements there might be in that extraction to the leach phase. That is step 1. So those results will be coming out towards the end of September. The great thing about the ANSTO work is that there's going to be 7 or 8 really interesting updates that come along with that test work program over the next 12 months. So starting at the carbonate phase, starting right at the beginning, let's try and optimize the leaching characteristics. We're already seeing 70%, maybe we can do a little bit better. And then culminating in 12 months' time with a 3-month continuous piloting program. So lots of exciting news flow coming out of that. Infill drilling. Now, this is really interesting. Meteoric has purchased an air core rig. Drilling is problematic. Contractor drilling is problematic in Brazil, so we've elected to do it ourselves. We've purchased a rig. We've employed a full-time driller. He's building up a team in Brazil at the moment. And the infill drilling that I'm talking about is really focusing on those two southern tenements that I keep referring to, the Capo de Mel and the Suburbo tenements, where we are looking to start operations. We want to develop over the next 12 months. We want to, within the next 12 months, deliver a resource update containing 200 million tonnes at measured and indicated. Currently, our 409 million tonnes is all inferred. So we'd like to improve the confidence in the resource with that drilling program over the next 12 months and update the market maybe this time next year, somewhere around there. IDing the basement is another interesting one. There's some geophysics to do there. That is really just some, it's going to be based on a methodology called ground penetrating radar. It'll map the hard granite basement. It'll give us some ideas of where the thicker zones are, where the thinner zones are, what the topography at that basement looks like. It's just an additional tool the exploration guys are keen to use to develop their understanding of the weathering profiles and how this clay deposit behaves. The scoping study is about to start. We've been going through a process with a bunch of engineers. We are very close to choosing a group to go forward with there. It's a 6-month study. That'll take us through to the scoping study level, but it's important work. It's going to give us some basic information that will feed into the line that you can see below the baseline studies. We need to understand what our mining areas are going to look like. We need to understand what our processing plant areas are going to look like. What sort of, and then from that feeds into the base of the environmental studies. We also need to get some understanding of what our capex is going to look like, and also what our operating costs are going to look at. So all those studies are going to be kicking off in the next few weeks or so. And at the very bottom, the environmental studies. There was an announcement recently that spelt out the status that we've been given by the state government of Minas Gerais. We have been given preferred project status. What that means is that they will support us through the environmental application process. It's looking to be a 2-year process to get us to a stage where we can start construction. Having that confirmation is really important to us because it gives us some definition around the timelines that we're now starting to build up with regards to when we think we can get into production. So great to have their support. That support has come through an MOU and also a tripartite agreement between us, the state government of Minas Gerais, and our EIA consultant. So between the three of us, we have a very clear picture of how those studies are going to look going forward and what those timelines look like going forward. And really, just to round off, just to give you an update on what news flow is going to look like over the next couple of months. As I mentioned before, the infill resource drilling, we are chasing 200 million tonnes of measured and indicated, so with a resource update due mid-2024. Metallurgical test work, as I mentioned before with ANSTO, we are looking for the first results to start coming through at the end of September, and then 5 or 6 news events through going forward over the next 12 months. Our scoping study, our final decision on a preferred engineering group is very close, and we'll be commencing that piece of work. It's around 6 months worth of work to complete that. We're looking to kick that off next month. Environmental permitting, as I mentioned before. Also, we have preferred project status with the state government of Minas Gerais, and we are just finalising the scope of our environmental consultant to take us through those 3 permitting stages over the next 2 years, which will ultimately end up with us having a construction permit, which will allow us to start constructing the mine facilities themselves. Exploration, lots to do in the exploration space. Not that we really need the additional tonnes, but as I mentioned before, we have a lot of land now that we need to take forward into the next stage to bring into good stead and convert those exploration and mining and those applications into granted leases. So lots of work to do in that space. And building out the management team. We have key appointments in Brazil now. Those positions are now all closed off. As we do in Perth, but it's really now for those managers to start building out those teams below them to allow them to have the capacity to take all these exciting work fronts forward. So thanks very much for your time. It's been, I'm really pleased to be able to share this fascinating project, this exciting project with you guys. Again, the key metrics and the hallmarks to the success of this project. We have a very high grade adsorption clay project. We know that. We know that it leaches with ammonium sulfate. It's a true absorption clay project. What that gives us is a very simple flow sheet, which means a low capital cost project, the low operating cost. So look, thanks very much for your time. If anyone out there has any questions related to the project, please don't hesitate to contact me, Nick Holthouse, CEO at Meteoric. I'm sure you'll have access to my email address, and I'd love to share more with you about this very exciting project. Thank you.